Morning, everyone. Everyone awake yet? I'm still getting there. Everyone had their coffee. So I'm going to talk about Amazon RDS. I'm not going to do very much as an intro. A lot of people kind of familiar with the service. We do a managed database service. There was a good talk on it earlier in the session. I'm really going to talk about what's new and some of the lessons we've learned in sort of talking to our customers and as we go with running a very large fleet of Postgres, kind of some of the things that we think are interesting. So we'll just jump right in. So what's new? Well, one of the big things that we did was we increased the amount of storage available in all of our Linux platforms on RDS. So you can get 6 terabytes of storage now. It's up from 3. One of the nice things about that is that if you're running GP2, it allows you to actually get more IOPS and more throughput. And GP2, I'll talk about a lot more later, is our general purpose storage, our SSD back one. It allows you to get a really good price performance. So by adding more storage, you can get more performance. And then one of the other ones that we had a lot of requests for was encryption at rest. We run some commercial engines. We have Oracle and SQL Server, and they have some built-in encryption. Of course, they charge extra for those things. The nice thing about our encryption at rest is that it's disk-based, so it goes on right off the bat. Doesn't cost you anything extra. Really not a big overhead at all because it's only available on the instance types for RDS that support offload for encryption, so it's quite good. And you can use your own key, so you can do all your key management through our KMS system, our key management system. And it's all the data files, all the log files. When we back everything up, it's all encrypted. So it's really nice if you have that kind of need. We've updated, and we have support for 9.3.9 now and 9.4.4. We had a bug in 9.3.6 or 9.3.5 that we fixed with 9.3.6. That's also, again, fixed in 9.3.9. 9.4.4, just a new release, and we added a few more extensions with 9.4. And I won't go into all of it, but every time we release, we basically update PostgIS, and then if there's a new PLV8, we do that as well, and we try to keep current. So let's talk a little bit about data movement. It's one of the things that we get a lot of conversations with our customers on is how do we get data in or out of RDS? So I wanted to spend some time talking on that. So we have a tool that's in beta right now, and it's called the RDS migration tool. And it allows you to basically migrate data or replicate data from a source that is basically on-premise or EC2 today, and it needs to be Postgres 9.4. Now, this tool actually works against MySQL, Oracle, SQL Server, and a bunch of other engines. But of course, most people here probably care about Postgres mostly. And your destination today can be EC2 or RDS. And it's really simple. It does an initial bulk copy, basically selects the data out of your tables, and inserts them into the new destination. But the real key here is it uses the logical replication support built into 9.4 to do change data capture. How many people know what change data capture is? Good. So you know how much of a better process this is than doing log-based replication because it just works off your log files. It doesn't put a lot of extra load on your system. So this tool uses that to mine what's going on. Now, of course, since 9.4 only supports DML-based operations, no DDL, the tool is really good at migrating because typically you're not doing a lot of DDL in the middle of migrating your database. But for ongoing replication, obviously that would be more of a challenge. So it has a nice GUI-based console. I don't know how clear. Yeah, it's not bad. You can kind of see it. So in this case, I named an EC2 instance. I just set up Postgres on there, pretty easy. And then I took an RDS instance I had, and I set them up. So you add them as databases in this tool. It takes about 2 minutes, tests them out, connects to them. And then I selected the tables, and here I have the pgbench tables. And so I said, yeah, let's replicate these guys to my database. Let's move those, because, hey, I wouldn't want to have to reload my pgbench data. That's painful. So it has a nice little screen here where it can do a full copy, and this shows that we're doing these 3 tables for pgbench. The first 2, the small ones, it zip through really quickly. And then the third one, which is, I think it was, 100 million rows. It took about 40 minutes to copy the 100 million rows, and I didn't set up checkpoint segments. I didn't do anything, so this wasn't really optimized or anything. But it took about 3 minutes for me to go from starting the tool to basically getting it moving the full load of data. And then once it completed the full load of data, you can move on to doing change processing. And so it'll start mining all your wall records and just start applying them. And again, the nice thing is you can do this. You can catch all the way up. And then you can just move to that database because it's open for writes. You just shut down your application, repoint it at RDS or an EC2 instance. So it's a really easy way to get your data into AWS for Postgres. So it's in beta right now. If you're interested in it, you can send me an email, Grant at Amazon. I'll hook you up with the product manager. We're moving into production pretty soon on it, but until then, it's on a sign-up basis. So if you're interested, let me know. So in general, we had, again, a lot of questions about loading data. The normal recommendations apply. Make it easier for the data load to happen. Disable your backups. That's going to take extra effort. Turn off multi-Z. Turn off auto vacuum. Now again, make sure you turn all these things back on when you're done. But it'll make it a little faster. Compressed dump, parallel restore. All good things. Increasing the maintenance work memory is kind of key. Jim noted it in his talk about vacuuming for building indexes. I'll show you how that it's important. Unfortunately, the way we set our parameters today, we just set maintenance work memory to 16 meg on RDS across the line. Yes, I know, surprise, Jim. We kind of needed to work on a way to set that dynamically. We have sort of ways to do it on basis of memory, but then it gets too large on the big instances. You'd end up with it set to like 30 gigabytes or something on a big instance, which may not be useful for you. So it's definitely one of those ones that you want to size depending on what you're doing. And then the other is we set the checkpoint segments to a fairly small value. Because it does use up disk space, and if you're on a small machine, you don't want to use a lot. But if you're on a big box, you're doing a lot of data loads, you want to increase your checkpoint segments and checkpoint timeout. And the reason for this is every time after you checkpoint, if you got to write the full blocks down if you're doing changing of data, right? So depending on the type of data loader you're doing, you can generate a lot more log data if you don't have your checkpoint segments set high. Again, it depends on how you load. One of the other ones that you'll see as a recommendation is to disable fsync. And this is the one that we disagree with. We think this is a really bad idea, and we've actually disabled it in our newer versions. Why? Because you can just disable synchronous commit, and you get all the performance benefits, pretty much, of fsync without the big risk. How many people know what turning off fsync does? Good. The education's slowly, getting out there. Fsync's really dangerous. Basically, what you're telling your database to do is, hey, don't worry about writing this stuff right now. And you might have written some stuff, not some other stuff. I've seen where if you turn off fsync and you create an extension and the box crashes in the middle, Postgres is super unhappy. There's bits of the extension installed, other bits are not there. It's just totally confused. That's a best case. You can probably fix that. I've seen it totally corrupt data. It's just not worth it because you think, oh, well, the chance that my box dies, fine. But a lot of people, they think, oh, I didn't get corruption. But you might have corruption you just don't see until later, so it's super dangerous. So one of the things that we like to do is we actually like to test, right, and see what difference it makes. So I did a 32-way threaded insert, and I'm comparing fsync versus sync commit, right? So 16 segments in blue, 256 checkpoint segments in purple. So with both of them on, you can see the checkpoint segments didn't make much difference. When I turn fsync off, I get a huge jump in performance. So you can see why people recommended this, right? Looks great. But guess what? Turn fsync back on, turn synchronous commit off, we actually get a better run, right? Because this is a higher TPS that we're getting. Now someone says, what if you turn both of them off? Would that be better? And it is slightly better, but only slightly, and mostly better if you don't have your checkpoint segment set. It's 4%. Do you want to risk corrupting your database for 4%? I don't. And so we don't think this is a very good idea. And just doing the synchronous commit change gets you 104% improvement on the load if you're doing an insert-based load. Now, if you're looking at doing more bulk load, yes, Josh?
In that test, what was wall buffer set to?
Whatever our default is. I'd have to look at what that is. I'm not sure. Are you saying that would make a difference?
Yes.
OK. So bulk load, in this case, we're doing a load where shorter times are better. You can see that by increasing the checkpoint segments, we get a nice increase or decrease in time, so better loading. Fsync off again, slight improvement this time, not as much on a bulk load because you're not doing a lot of commits, right? Synchronous commit, you see about the same performance, both off, a slight improvement again. And again, we see about 3% difference here. So again, I don't think it's worth turning this off. Now, talking about index building, does it make any difference here? So we started with a really small number of checkpoint segments, 16. and a very small amount of maintenance work memory, basically the defaults of what we set at, right? Not very great numbers, 29 minutes to build this index, and it didn't really matter synchronous commit on or off, or fsync on or off. We get a nice improvement by just moving the checkpoint or the maintenance work memory up to a gigabyte, right? Because this allows the index build to go faster. It has to do less work to disk. And increasing the checkpoint segments, again, helps. So what you want to do, what I'm showing you is, I'm not saying these are the best numbers ever, but they show you that testing the stuff with your system is actually really important to figure out what are the right numbers for you to set. Because I did a test here just building this index on the 20 gig table with 16 meg, we saw 29 minutes. When I went to 4 gig, I see 28 minutes. So I didn't actually see much of an improvement. I see better times with the 1 gig, and I see about the same time with 512. So again, it's going to depend on your I/O system and a bunch of other things, and you want to test these things to really decide what are the right settings for your system. The other one we get a lot of conversation about is vacuum. As Jim's talk showed, lots of people were there. Vacuum is a really good topic in general, because you may not have a problem with it right now, but probably sooner or later, if you have a busy system, you're gonna run into some fun with it. But one of the things that I found was really interesting is that most people don't understand, like, if you do a bulk load, you need to vacuum after that, and you need to analyze. And if you don't, you end up seeing some really weird conditions. And this was a great one where I'd done a big bulk load, and then I start running a read-only pgbench workload. And you can see that green line. That's my write IOPS. And you're going, I'm doing a read-only workload. What is Postgres doing here, right? The CPU is moderate. I'm getting 21,000 TPS. It's not bad. But I stopped and I vacuumed, because essentially, as I was reading, Postgres is writing those blocks. It's cleaning stuff, right? It's doing work. Once I vacuumed, it's all nice and clean now. And you can see when I restart it, I get 45,000 transactions per second, right? Because I'm not having to write any data when I'm reading it. So doing vacuum, doing analyze after doing data loads is really critical to make sure that Postgres has the information it needs to run and do your job. I won't go into too many of the vacuum parameters. Like I said, Jim and other folks have talked a lot about these. These are just some of the parameters that you want to think about when you think about whether or not you can keep up with vacuuming, right? If you don't do these things, what happens is you can get transaction ID wraparound, and this is really painful. We've had a couple customers hit this. They're not very happy when that happens, and we have to help them out, get them out of that state. And it's, sometimes it's just doing kind of interesting things. Like, we had one customer who was inserting into a table and hitting a ton of primary key violations. Every one of those rollbacks generates a transaction ID, right? And so you can go through transactions much more quickly than you'd think. So when people say, hey, you got 2 billion transactions, it sounds like a pretty big number. But if you're doing 100,000 TPS, but it's all rollbacks, your data is not really growing that fast, but your transaction ID space is being used very quickly, right? So these are some of the parameters that you want to look at and make sure that vacuum is keeping up with your stuff. And as I said, looking at Jim's talk would be a great way to get more detail on that. So another thing that we added around data movement is the ability to use the Postgres FDW. And I like to show this one because instead of just connecting to another Postgres instance, I connected to an Amazon Redshift instance. It's running an older version of Postgres, as some people constantly ask us to update. But I always give that feedback back to that team. But it's modern enough that you can use Postgres FDW to connect to it. And it's pretty simple. You basically just create the extension. Now, you have to use the RDS super user, which is our equivalent of super user inside of RDS. So, and you can grant this to other users. And it's the one that allows you to do stuff like create extension, killing sessions. So we do the create extension. And then all we do is we specify the name that we get for Redshift. And we create a user. And hey, look, we can count from the table. We can insert into the table. It all works. This is another way for you to move data in and out of an RDS instance by using an FDW. It wouldn't be great for necessarily bulk loading, but it's a way you can easily move data in and out. One of the other things that we added is support for the session replication role, which isn't actually a role per se, which is why it's kind of a funny name. And what this allows you to do is really control some of the replication on trigger-based replication. So this is a requirement for using products like Loandeast or Bucardo. And just to explain it, I got a little animation. So if you had a trigger on a table that replicated to another table and then it replicated back, if you did that insert into that table, that insert's going to hit the trigger, it's going to fire, and the insert's going to basically flow over. Ooh, that was weird. It's going to flow over to the other side, and then it's going to keep going around in a circle. Sorry, my animation for some reason isn't working. I borrowed a computer, so once that, it'll just keep going in this little loop cycle over and over again. The session replication rule allows you to program and say, no, if this is a replicated, I don't want you to keep replicating it. So it just allows those tools to work. So we do support those today. I mean, we're not experts in those tools or anything, but they do work. And you can use something like Bucardo. Now you have to use an on-premise or EC2 instance as the controller because you have to install one of the unsafe languages. But it does allow you to do things like replicate to RDS, replicate back from RDS, back and forth, multi-master. Now, some of these tools, again, they're trigger-based, so that how good they scale and how well they work, everyone's experience is kind of different with them. But at least if you have those needs, we do now support that with RDS. And you can actually even do RDS to RDS replication by using Bucardo as sort of the middle person. Not that you necessarily want to do that per se, but it is possible. So let's talk a little bit more about scale and availability. We get a lot of questions in this space as well. One of the other ones that we talk to customers about is shared buffers. They go, what should I set my shared buffers to? There are some great myths out there. How many people have heard that you should never set your shared buffers greater than 8 gig? Yeah, so that one used to be one that was sort of espoused by some folks, or never set it to more than a quarter of your memory. And some of it was based on the systems they were on. Some of it was based on the version of Postgres. We default to a quarter of the memory of the system. It's kind of the generally recommended thing to do these days. So that's where we start off with. What we found, though, is that because Postgres uses the page cache to cache its data, if you're only putting a quarter of the memory in the shared buffers, that means the page cache has to manage a whole bunch of memory. And this actually can cause a lot of jitter and a lot of sort of OS work on your system that you may not want. Now, again, it all depends on sort of what your working set size is. And so what I tell people, again, is test, test, test. Understand what you're running. Test your system if you can. If you've got a test system, really go and look at what changes might work better for you. From what I've seen, setting your shared buffers equal to or right around your working set size is the one that you normally get some of the best performance at. Now, again, this will vary. There are some corner cases. There's people at this conference that know a lot about the internals of Postgres, and they'll tell you, oh, by the way, if you do this one thing, it's going to be very horrific if you have large shared buffers. But in general, I think it's a pretty reasonable recommendation, or at least something to test. So I went and ran pgbench on a write workload on an R3 XL. So this thing has 256 gig of RAM, so quite a large cache on it. And I started with a test where my test size for pgbench was the same, was 10% of the working memory, or 25 gigabytes. And then I basically ran a whole bunch of different thread sizes, like started with 25 threads, worked my way up to 800, and you see that on the right hand. TPS is on the left, sort of a standard benchmark. And on the bottom, we have the percentage of shared buffers as a percentage of main memory. So we start with 3% and go all the way up to 75. So the red line here I have shows sort of the ground between their working set size fitting in memory on the right-hand side, or it not fitting in memory. So if we only have 3% shared buffers, that means, hey, look, we're about 3 times the size. And notice what we get as a result. We get slightly better performance if we fit into our shared buffers, right? Now, it's only 5 to 6% at this point, but it's still a good improvement. And the thing you'll also notice is, notice when we go to 25 or 50% or 75, we don't get a large increase in performance, because essentially we've got the benefit of not having to go outside for buffers, outside the shared buffers. But going larger doesn't necessarily help and may actually run you into other issues. But probably much more commonly, you're probably going to run something like a working set of more closer to 50% or bigger on your instance, right? So I ran that basically same test, but now with 128 gig as my working set size, right? And again, the red line sort of denotes whether we're fitting in shared buffers or not. And we see a bigger performance boost this time, 3 to 20%, right? Because and especially at the higher levels of concurrency. So this is just showing you that not having to go through the page cache actually can help your application perform better if you set your shared buffers higher. So again, just some guidance there that might be useful. The other question we get is because we support multiple forms of replication for availability. The first one is our primary redundancy, which is called multi-AZ. And what it does is does synchronous replication. And we think it's the best method for providing availability. But depends on your use case. So let's just walk through what multi-AZ does. So we have availability zones. How many people have heard of availability zones before? It's pretty much, so a few folks. You can almost think of them like a data center. It's not quite that, but they're separated physically apart from each other in a region. And we have regions all over the world. So you can pick a region, and then you get like 2 or 3 or 4 availability zones in each one. So I just made fake named ones called AZ1 and AZ2. Typically, you'd start setting up your database like this. You have your application, and you just have your database in one availability zone. But of course, what happens if something happens to that machine or that availability zone? You're going to be down. So what we recommend, of course, is that you want to have a secondary, right? And you actually want to have your application also running in the other data center, or availability zone, as I should say. Multi-AZ does it physical synchronous replication. So it's physical like wall replication. Unlike some forms of logical replication, this means it can keep up. It doesn't fall behind. The main difference is the synchronous replication with backoff allows you to be guaranteed that you're not going to lose data if it's replicating, right? Versus asynchronous replication, hey, you might be a little bit behind. If you have to fail over, you're going to be missing some data, which may be fine for your application, but it may not. If you're a bank, if you're sending customers product, you really don't want to lose the fact that you just shipped a $20,000 order out, that you're going to ship it out again, right? So what we do is when the availability zone or the system has a problem, we'll do a failover. So we promote the secondary to become a primary. Now people ask me, well, but how does my application know? Well, what we do is you connect through a CNAME that you get from DNS, right? And it tells you basically where to go. So when we promote the primary, we update DNS, and that flows back to your application, and your application can connect to the primary. This takes about 65 seconds to happen. So that's from the detection to the failover, through the DNS propagation, and out, and the TTL on the DNS. That's about how long we see for our customers. Once that's done, everything's back working again. This works great. And it doesn't matter whether the whole availability zone goes down because you have your application server in the other availability zone, so you'll keep functioning. And of course, once the availability zone, we basically repair it immediately and rebuild your secondary and get you back into a durable state. So this works really well for a lot of folks. But for some folks, they want either more read availability or they don't need the guarantees of synchronous replication. So a lot of times we'll have customers that'll set up synchronous replication, multi-AZ, with us, and they'll start off this way, and then they'll add read replicas. And these are just Postgres streaming wall replication. So there's nothing fancy about it. It's just asynchronous replication. And I tell folks this is really useful for a lot of things. And you can get higher availability if you architect your application to use these. Because if you split your application, let's say you're writing a blog site. Well, you have writers that need to write to their blogs. So they're going to need to talk to the main database because they want to write and they want to see that right away. But all the people reading the blogs, they don't need up-to-date, last-second versions of the blog. They just need to be able to see it. So if you split your application into those things, you can actually direct those eventually consistent reads to your read replicas, right? So in the case of, let's say we're going to fail over multi-AZ because the primary failed, well, there's a little bit of time, as I said, there's that minute where you're not going to be able to write. But hey, your blog guy, he can just wait a minute before he has to write a new blog, right? I mean, I know bloggers would be upset if they can't be writing, but right, Stephen? But the readers, they can basically continue to read continually, right? So you don't have any read downtime during something like this kind of event. So once we all back together and you fail over, it's all back working again. So this is a nice method to really add an extra level of availability to your application design. And even if when you have to let's say, do an upgrade of Postgres, you can read from your replicas. And because you can have many of them, you can take them down one at a time if you need to modify them for some reason, scale them up, or do whatever, or replace them. So that's really useful. The other thing, of course, for read replicas is a lot of people use them to scale up. This is very common in the MySQL world. Postgres, I think it's becoming more common with our customers as we go. And the customer will start with, again, with the multi-AZ with synchronous replication, and then they'll add read replicas in each of the AZs, so it gives them lower latency for their application by like a half millisecond or a millisecond, but it also allows them to scale. And that's a nice benefit of that. So one of the things to think about when you think about read replicas is how good of scale you're going to get depends on how much writing you're doing to the database. If you're only writing 10%, well, that means pretty good. You can scale a lot, because if you think about taking those reads and moving them to the read replicas, you really reduce the load on the primary. Notice the writes have to get, the write workload still has to happen on the replicas, because you're sending the wall over, it's got to be applied, right? So it's not like it's free. So you can easily get, move that over and have lots of room, so you can get 2x scale, maybe 3x scale. It really does allow you to get a lot more scale. I mean, we have folks, today we allow 5 read replicas by default that you can have on your instance. But if you want more, you just basically have to talk to us, and we can up that limit. And we have customers that are running today with 15 or more read replicas, off of one primary. And, the interesting thing is I have people that come to me and they have, a mostly write workload, and they're like, well, read replicas work for me. And you can see from this chart, if you're running 50% writes, to get 2x scale, you'd need 32 replicas. So probably not a great investment or a strategy that you'd want to do. But if your write rate is 10% or below, read replicas are a great way to get scale on your application. Now, one of the interesting things is promotion of read replicas. So when you have logical replication like MySQL, people do all kinds of interesting things around promotion, because they'll go and do schema changes and other stuff on the logical replica because they can change it. But Postgres is wall-based. It's physical primary replication. So you've got to match. It's a binary copy of your database. You can't go do anything to it. So promoting it really only makes sense for a couple of reasons. One is you just want to split off a server really quickly just to create something. And the second is, of course, if there's some kind of failure and you want to promote it. So if you're not running multi-AZ and you need to promote it, you just go run the promote command with RDS, and it just essentially turns that replica into a new primary. And then you can connect an application to it, a different one or the same one. But you'll notice that the other read replicas that were attached to the primary didn't change, they don't follow. So the way it works with us, if you promote a read replica, it just becomes a new standalone RDS instance. And you can add backups, you can add multi-AZ to it, you can do whatever. It doesn't, it just looks like a regular one. Some people's systems, they try to have all the replicas follow the new one. We don't do that. So just one of the things to be aware of. So one of the things to think about when you're setting up replication is some of the replication parameters. So we do streaming replication by default, which is really good, very fast, low latency. Typically we see only milliseconds. Like even when I was pushing with 15 replicas, I saw less than 100 milliseconds of lag, on pushing a really hard pgbench against replication with streaming replication. But sometimes streaming replication can break. And if that happens, your logs start accumulating on the master, right? Or on the primary. And the problem with this is that you have wall keep segments set to a particular value. And once that value is hit, let's say we set it to 99, it's going to start removing logs. Now, the nice thing is we upload the logs to S3 as part of the point-in-time backup, right? So we have them. So we can still apply them. We can apply them to your read replica. And that works pretty well, but you still don't want to necessarily break streaming replication because you don't have enough wall keep segments. And so we've seen people that have not enough wall keep segments. They basically switch back and forth from streaming to us pulling logs down, and the replication lag is bigger. So you really want to make sure your wall keep segments is going to be large enough, because we will basically catch up and get you back into a streaming replication mode, but you want to set that to a reasonable value. Now, we don't set it super large again because we don't know how much disk space you're going to want to buy. And if we set it to some large number like 10,000, well, then you'd accumulate a ton of logs on your system that you may not actually want. One of the other things to think about with replication is how vacuum sort of affects your read replica. And I've just done a little thing where I have a source and a replica, and I have a column, or a little row there called a foo, and it's on the replica. So if we go update that, well, first let's run a log select. So we're running a select star from T1. It's going to do a full table scan of this table. It's going to take a couple hours, right? So we run an update on this. So we set it, set where the pk equals a to a new value. So we set it to bar. And Postgres, you get a new row basically in your system, right? That's the green row. And that row will get replicated down to your replica. Everything's good now, right? Because of MVCC, you don't actually see it in your select query. Everything just continues on. But what happens if someone runs vacuum or auto vacuum runs on your source? Well, essentially what that's going to do is it's going to remove the old row, right? The AFU record is gone now. You don't care though, right? You're running on the replica. Except for guess what? The replication is going to replicate that down to your replica, and it's going to go away, and you're going to get this nice error message, which means you just broke your queries. So if you're running long-running replication or queries on your replica, you really want to not have this happen to your users. So there's basically 4 different parameters that you can kind of use to control these, and I'll go into detail of each one of those. So vacuum defer cleanup age, it's kind of an interesting one. I don't know how many people use it anymore. You set it on the primary, and it's the number of transactions across the whole system to keep and to stop vacuum from cleaning up. How many people would say, I know how far back in time my last 1,000 transactions were? That's a pretty hard thing to think about because it's not time-based, right? So I just have an example here where I change again one row. And let's say on the replica, I need T4 because that's where I'm selecting from, right? Well, normally if I do a vacuum, it's all going to disappear. I'm going to get that error. Now, if I set, for example, vacuum deferred cleanup age to 2, well, it would keep the last 2 transactions, so I wouldn't fail. But the chance of you setting this correctly, I think, is very slim because of the nature of the model, right? So the other one that I think a lot of people used at one point was max standby archive or streaming delay. And you need to set both of these on RDS because we use both models. So essentially, let's say you set that to 30 seconds. What that's going to do is you're essentially going to stop applying the wall records to the standby or the replica if there's a conflicting query. But the interesting thing is it'll delay it, let's say, for 30 seconds, but then it'll let it go and your query will get killed. But the next guy coming in will not necessarily get 30 seconds of wait time because the wall can only be 30 seconds behind. So you will actually, the next guys will actually not see 30 seconds, so you don't necessarily, you get up to 30 seconds of delay of safety, right? So again, it's a very hard parameter to set because of this nature of this, right? Now it's nice because it's very guaranteed about how much delay you will have on your replica. So if you're more concerned with making sure your replica is up to date than you are with having queries get killed, it still can be very useful. The one I like is hot standby feedback because to me it sort of makes the most sense. If you're doing streaming replication, it's in the replica, on the replica's configuration file, or in our case, the parameter group. It's off by default. Once you turn it on, essentially it's a back channel from the replica back to the primary. So it's communicating back to it what's going on, essentially. So if you do that long-running select on the read replica, it's like it ends up running on the primary. Now, it's not actually running, but it does the same thing. It will cause auto vacuum to not actually work at that time on that table while that's going on, just like if you were running a regular select. So this is super useful. But one of the interesting things, of course, if your streaming replication stops for some reason, remember, we'll keep applying log files. But because if that connection is broken, it means that we're no longer giving feedback, and if the auto vacuum runs, it would actually break it. So this is why sometimes you have to set both things like the streaming delay and hot standby feedback to get what you want from your replica. You can see this kind of information in pgstat database conflicts, where you actually have information about conflicting snapshots and other things that are going on. So you can use this view to figure out what's going on with your replica in this case. You can also use pgstat replication to understand whether you're streaming, whether how you're applying logs. And in this case, you can see we're in streaming mode on this database. So that's it for replication. One of the other things we added, kind of visibility into the database around performance, was the ability to set up pgstat statements. This is an extension, but unlike most extensions, this one you actually have to load as a shared library first. So you have to go into your parameter group and apply this one. It will require a reboot because it's a non-dynamic parameter. So if you like to use this, basically you want to set this up right off the bat before you need it. Because of course, if you're having performance issues, you don't want to have to tell your boss, oh yeah, for me to figure out what's going on with their database, I'm going to need to bounce it first. That's probably not going to, not going to be the best manager meeting you've ever had. And once you do that, of course, you create the extension and you can see the information about what's going on in your database from sort of what each statement's doing. Some of the things that we added support for based on our customers is PLV8, the test parser extension. We update new PostgIS versions, including support for the Redshift files. And we added support for shared preload libraries. Of course, at the moment, the only one we support is pgstat statements. So one of the things I always tell everyone is that how we decide on what extensions to have for RDS is based on the customers. So if you use RDS or you want to use RDS and you look at the list of extensions that we support, and you can do that by just doing a show rds.extensions on an RDS instance. So for each version, it's slightly different because we add ones over time. That if you say, look, I need this one, well, come and ask us because we'll be happy to go look at it and see whether or not we can add it. Now, we don't run the unsafe extensions because of our being a managed service. Question? No, it's considered safe. Well, ish. I mean, all languages are safe-ish, right? I mean, they're just the ones we know are completely not safe. So, yeah. And then the other thing, we've got a few minutes left. I wanted to talk to you a little bit about one of the things that I think is really interesting that's going on sort of in this space, which is really about burst mode computing. So, I mean, the cloud is really good. I love virtualization. Whenever I have to go back and work on physical boxes, which is really rare these days, it's so painful. Like I got to call somebody when the machine gets stuck. But I've now sort of transitioned past that. Now I'm just like, I'm a virtual guy. I like virtual instances. The new thing I love is I love burst mode computing. So what this means is you get a set amount of credits. And in the case of GP2, which is our storage one, you get 3 IOPS per every gig. If you don't use those 3 IOs per second, they build up, right? So then you can burst and use them later. And you can go to 3,000 IOPS or more, depending on the configuration of your system. And we have the T2 family of servers, which today we support the T2 micro, the T2 small and medium, and soon to be the other ones as well. They do the same thing. They have CPU credits. If you don't use your CPU, you basically get to store it up in burst. The nice thing is that the EC2 guys actually have metrics, and we keep bugging the EBS guys to get metrics for theirs too. And you can actually see this in CloudWatch. So here I've graphed with CloudWatch, and I have the green being my CPU, and the orange line being the credits. So you can see I'm running this workload, and I'm slowly chewing through my CPU credits, right? And when I exhaust them, I drop down quite a bit in performance. But I did manage to run for a couple of hours like that, and it really actually makes sense from a cost perspective, and that's what I'll show you next. So we have what we call our older lines, are kind of ones that we started with, like the DB M1 Medium. So these are not sort of our current hardware. So I picked one of these older instance types and used our magnetic or standard storage, just to give you an idea of this is sort of representing what we had in the past, although you can still order them today from sort of compatibility reasons. And I ran this benchmark where, transactions per second, again on the vertical axis, and I ran it for 24 hours. So you can see that I'm getting basically reasonable performance, like 1,200 TPS for about 58 cents an hour. Okay, not bad. So then I went to one of our newer generations machines, an M3 Medium. So this basically has the same amount of RAM as the M1 Medium, but I also put provisioned storage on it. So this is our provisioned IOPS. So I said, I want 200 gigs, same amount of storage, and I ordered 2,000 IOPS. And you can actually see what's interesting is it's a more expensive for our I/O, but the new generation of machine is actually less expensive. So we actually ended up spending about 41 cents an hour and doubling our throughput because we have more IOPS, right? Because we were actually limited early on IOPS. So this shows you sometimes you actually, like by using something that seems like it might be more expensive, you actually get better performance. Now, I went and said, well, what if I add a large to that? Would it help? Well, it actually helps a little bit. So this is why it's always interesting to play around with scale. A little more memory helped this particular benchmark. And I got up to 3,000 transactions per second. and it cost me 51 cents. So, possibly a good price performance, maybe not. But then I wanted to look at what the burst mode computing could offer. And so I did a T2 medium. So again, it has the exact same amount of RAM as the M1 medium and the M3 medium, but this time I used also burst mode storage of 200 gigs of GP2. So what's interesting is you can see that the graph kind of has a little bit of a jag to it. Well, what happened here was, for the first 2 hours, I was running really good. I was getting almost 3,500 TPS. But then I ran out of credits, and so on the GP2 volume, right? So I'd exhausted them all, and I go much lower. But look at that cost per hour. It's 11 cents, right? So if I really only needed to burst to that level for 2 hours a day, I'm saving basically 4x the money, right? So this is a very powerful model to allow you to really be much more cost effective. But the cool thing with GP2 is, guess what? Because I get the IOPS I get is based on how much gigabytes I buy. So if I want to, I can just go buy more storage. So in this case, I was like, I will buy a terabyte of storage, even though I don't need it. And look at what I get off the bat. I get 6,000 TPS, right? So I got a huge increase because I have a lot more IOPS, more so than even the PIOPS, because remember, I bought 2,000 there. With 1 terabyte of GP2, I'm guaranteed 3,000 IOPS, right? That's not even burst. That's just all the time. So again, I drop down once I exhaust my burst, but notice I'm still running at almost 4,000 TPS. Now, it's not till the very end here where I run out of credits on the T2 medium, right? So I get throttled down, but look at that. 18 hours I managed to make it before I got throttled with this one. And it's 23 cents, a little over 23 cents an hour for something that's producing, at the end of the game, the same as something that was 41 cents an hour, right? So I really think you're going to see more and more sort of burst mode activity in this area, because for a lot of workloads, they're not consistent like this benchmark where they run at the exact same pace the whole time. They actually burst a little bit, and so you can get much better cost economics out of running these kind of systems. So that's it for me. I got a few minutes left, so I'll happy to take questions on any of this or RDS. The question was, do we have the ability to do cross-region replicas? Not at the moment. It's something we're getting a lot of requests for customers from, and it's definitely something that we're looking into. Anyone else? Questions? Good. So the question was, do we offer PG pool for sort of data center affinity or routing kind of stuff? Not at this point. It's definitely something customers have talked to us about. At the moment, because it's sort of almost a little bit of a middleware component, we kind of leave that up to the customer to run on their behalf. But I mean, definitely customers have said, hey, look, you do such a nice job managing RDS. Could you do more for us? And it's definitely something we'd love to get some feedback. We could talk afterwards about kind of your requirements. Yeah, yeah. Other questions? Josh.
Why do you still make other patch versions available? Why is 9.4.1 still available for new instances?
That's a good question. Why are older versions still available? There's a lot of complexity to that answer. To some degree, we want to make sure that customers have the ability to move when they want to. Definitely when there's higher security risk items, we tend to what we call, we have basically a multi-step process. So we have this feature called auto patching equals true. And that's to help customers sort of keep up if they don't want to have to pay attention to the versions, and we'll move them forward. But at some point, we actually do deprecate older versions, and we do sort of force people to move up to newer ones. But I think we could be more aggressive in our retirement of older versions. We do actually have a sort of a contract with the customer that says we will allow them to run older releases for up to 15 months if there's not a security issue with the releases. Now you could ask, why don't we make things default to the newer ones sooner, which is something that I'm actively pushing the team to make sure that we're doing on a more regular basis. Other questions?
Are you able to run something like pgbench inside of VPC connected to RDS?
Yes. Sorry, the question was, can you run pgadmin inside of a VPC connected to RDS? Yes, you can. I mean, and it depends on how you want to do security, right? If you don't want your database to be publicly accessible, a lot of people, what they do is they do some kind of tunnel forwarding through a bastion to get something like pgadmin talking to their database, right? So you can do that where you can have pgadmin on your PC that's going to basically some kind of bastion host in your VPC that is publicly accessible that then allows you to transition into your RDS instance. Josh?
Currently for load balancing in AWS, I'm using HA proxy.
Okay.
Because I haven't found that elastic load balancing really works all that well with RDS.
Okay.
Am I missing something that would actually make it work better?
So the question is really about load balancing using our elastic load balancers versus something like HA proxy. I haven't spent a lot of time actually looking at that. I think it's something we could take a look at and see if there's. I'd be happy to get feedback on what kind of issues you're seeing, and we could definitely talk to that team about seeing if we could improve that experience. I'm not aware of them personally. So, other questions? Yes.
Right. So the slide you had where you had all the different instances.
Yeah.
IOPS. To me, this has always been one of the problems with AWS. It's like a black art to even figure out what instance you should run.
Yes.
Do you have any good like resources or articles that have been written that kind of break down what you talked about in a manageable form, and maybe it's kept up to date as the new instances?
Sure. Yeah, I mean, we do have some guidance on our our website about this sort of the question of like how do you pick what instance types. I do think we have a lot of instance types now. Sort of we have the older ones, and then we have sort of the new generation. And obviously, I would recommend the new generation because the price performance and everything is always going to be best. Like so, if there's an M1, an M2, an M3, and an M4, you want to be on the higher number. But we don't have a lot of great written stuff other than just what the web pages are today. I would say we have essentially the lines when you think about it on the M is sort of a mixed mode where the memory and the CPU are sort of balanced, and then you have the R line, which is obviously where you want more memory instead of CPU. I mean, it's still got a lot of CPU, but you have a lot more memory per each CPU cycle. And then the T's are basically like the M's, but with burst mode.
Well, but in particular, the kind of trick you were showing there is that you actually do better if you just provision a lot of storage.
Yes.
You get the IOPS.
Yes.
Because you're getting a certain number of IOPS per
Yes.
gigabyte. And so you actually end up doing better if you just provision a whole bunch of storage
Yep.
rather than actually getting provisioned IOPS,
Yes.
et cetera.
Yes.
I mean, that kind of trick is not
But-
obvious.
Yes. But I wouldn't have anything to present about if I just had that on a web page. No. No, I think this is one of the things that we're definitely trying to get more socialization around. One of the things was there was a couple funny things about GP2 to start with before we were pushing it heavily. If you had a very small instance, you would get something like, let's say you had 10 gigabytes. You would only have 30 guaranteed IOPS, right? So what we had customers do is they would do a ton of work on their instance, and they would burst up to 3,000 IOPS. And then their instance would slow down dramatically when they ran out of IOPS. And then some customers rebooted their instance, rebooted their database because they thought something must have happened. Well, that caused it to do crash recovery. Have you ever seen Postgres do crash recovery of like a really large amount of segments with 30 IOPS? It takes a really long time. So we've made some changes to get like the basic GP2 to have 100 IOPS sort of to match the standard magnetic. So that the performance is sort of better all around than the magnetic one, and we just kind of rolled some of those changes out. So I think as we kind of clear these last couple hurdles around GP2, you'll see our literature become better on sort of advising that. Because I think Sarah was the one that mentioned, I think our documentation still says that, oh yeah, the magnetic is still like, kind of the best default choice if you don't need performance. And it's actually not as cost effective as GP2 because you pay for IOPS on magnetic and you don't pay for IOPS on GP2. It's a fixed charge. So, again, I think we do need to update our docs on that stuff. Cool. One last question, and then.
Just related to that, would it be possible to, probably hard, to build a simulator for past billing cycles to say if I had changed my instance type to this is what it would look like?
Yeah, I mean, it's
Have my data.
yeah, well, we have your data, but we don't necessarily know your workload, right? And I don't know your working set size and a bunch of other stuff. So it is very challenging. The thing I would tell you, it's really easy to fire up a test copy of your instance, though, and run tests, right? And with that, I probably should go before Stephen beats me with the sign that says 0 minutes. Yeah. Thank you very much.